Hello again. In this video, I'm going to work out some examples where we use Theorem 3.15. Remember, Theorem 3.15 says that the derivative of ln of x is 1 over x. The derivative of the natural log of the absolute value of x is also 1 over x. And then it also says that the derivative of ln of the absolute value of u of x is equal to u prime of x divided by u of x. Okay, so let's look at some problems where we use this theorem. So let's say we have y is equal to natural log of 4x, and we want to find dy dx. If we're going to find this derivative, we're going to have to use the chain rule because this is a composition of two functions. The inner function in this case is 4x, so I'm going to call that u. Then the outer function would be ln of u. Because 4x is equal to u. Okay, and so the chain rule says that dy dx is the same as dy du times du dx. Okay, so let's find dy du. Now the derivative of y with respect to u is simply 1 over u. And that's coming from Theorem 3.15. Because the derivative of ln of x is 1 over x. Now, we have a different letter here. We have ln of u. We're taking the derivative of that with respect to u. And so we do get 1 over u. Okay, now du dx, the derivative of this with respect to x obviously is 4. Okay. So if we multiply those together, right, this is the outer derivative times the inner derivative. We get 1 over u times 4. Of course, let's go ahead and replace the u. U is actually equal to 4x, so it's actually 1 over 4x times 4. And so the 4's cancel out, and we just end up with 1 over x, which is kind of odd, because that's the same as the derivative of natural log of x. So it really doesn't matter if I take natural log of 8x, the derivative of it with respect to x will end up being 1 over 8x as the outer derivative, and then the inner derivative would be the derivative of 8x, which is 8. 8's are going to cancel out, and you're going to end up with 1 over x. So this is not a coincidence. This always happens when you're taking the derivative of something like natural log of a constant times x. Okay, let's look at another one. All right, let's say you want to find the derivative of x times ln of x with respect to x. Okay, so to find this derivative, we're going to have to use the product rule because that's the product of two different functions. Okay, so the product rule says you take the first and you multiply it by the derivative of the second, and then you add that to the second times the derivative of the first one. Okay, so the first one is x, then times the derivative of the second one, which again, by Theorem 3.15, the derivative of ln of x is just 1 over x. Okay, so that's the first times the derivative of the second, plus the second function, right, which is ln of x, then times the derivative of the first function, which is equal to 1. Okay, and we can simplify this. Here these x's cancel out, and so you're just left with 1 plus ln of x. Okay, so that's the derivative of this function with respect to x. Okay, now let's look at this one. Okay, so let's find dy dx. Now again, we're going to have to use the chain rule because this is a composition of two different functions. Okay, and so let u be the inner function, which is secant of x. That means the outer function is going to be ln of the absolute value of u. Again, because we're replacing this with u. Okay, and then again, the chain rule says that dy dx is the same as dy du times du dx. Okay, so dy du, the derivative of this is just 1 over u, right, by theorem 315. Now, the derivative of this with respect to x, right, du dx, the derivative of secant is secant times tangent. Okay, and now let's multiply those together. Right? This is the outer derivative and the inner derivative. In fact, let's just go ahead and substitute for u here. U is secant of x, so this is really 1 over secant of x. Okay, and now we're just going to take the outer derivative and multiply it by the inner derivative. And of course, these secants cancel out, and you end up with the derivative being tangent of x. Okay, so the derivative of this function is just tangent of x. Okay, and now let's look at this last one. We have natural log of x squared divided by x squared, and we want to find dy dx. Now, in order to find this derivative, we're going to have to use the quotient rule, because we have a quotient here. And one suggestion I have to make it a little bit easier is anytime you have logarithms like this, there's a property of logarithms that says you can take this exponent and multiply it in front of the logarithm. And generally speaking, I would do that before you actually find the derivative. It usually makes finding the derivative easier. So I think that's a good practice. And so I'm going to rewrite this before we find the derivative. This is the same as 2 times the natural log of x. Again, you're allowed to take this exponent and multiply it in front of the logarithm. That's just a property of logarithms. Okay, so after rewriting it like that, let's go ahead and use the quotient rule. So again, the quotient rule says you take the low times the derivative of the high minus the high times the derivative of the low, all divided by the low times the low. Okay, so we start with the low, and then we multiply it by the derivative of the high. Now, the derivative of this high part, we can pull the constant out front of the derivative operator, and then we're left with the derivative of ln of x, which is just 1 over x. Okay, so we end up with 2 over x. 2 divided by x here. Okay. Okay, so this is the first, the low times the derivative of the high minus the high times the derivative of the low, which of course is just 2x. And then all of that is divided by the low times the low, which of course can be written as x to the 4th power. Okay, let's just clean this up. The x's here cancel out, and you're left with 2x minus, now the order in which you multiply doesn't matter, so I'm going to take this 2x and multiply it by the 2 first, and that's going to give us a 4x. Then I'll multiply that by the ln of x. And then all of that is divided by x to the 4th power. Now we can simplify this a little bit more. Notice on the top here you can actually factor out a 2x. So I'm going to go ahead and factor that out. And that's going to leave you with 1 minus 2 times ln of x all over x to the 4th. And then one of these, this x here, will cancel with one of these x's in the bottom. leaving us with x cubed on the bottom. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.